Hi everyone. So today we have to just wrap up a couple more types of factoring. So this is in your factoring notes. And we're going to be looking at the section 2, factoring difference of two squares. Um, this type of factoring is the easiest type of factoring we're going to see. It's also the one people forget about the most often. Okay, so I I see people, even once we get really good at factoring, they run into a problem like this and they go, wait a second, I don't know what to do with it. You have to recognize it for what it is. Okay, so what I'm going to do is I'm actually going to start with an easier problem than these. Okay, I'm going to start with this guy, x squared minus 25. Now, at first glance, that doesn't look like anything we've factored before. There's no GCF I can pull out. There's not enough to do any sort of grouping. Um, it's not a trinomial, but I can make it a trinomial because what it's missing is the x term, right? So if I think of this as x squared plus 0x minus 25, now I can factor this just like, let's see, where are they? These ones that we did, okay? Where we were just going, x plus 9 and x minus 4. Those ones that you guys said were so easy. I can treat this one that exact same way. X squared plus 0x minus 25. So if I think about it that way, I know I'm going to start with an x and an x. Looking at my signs here, because this is negative, I know I need one positive and one negative. And then I need numbers that multiply to 25. And then when I include the positive negative aspect, I need them to add up to 0. Okay? And I hope you're wanting to yell at the screen right now that it would be 5 and negative 5. Okay? Because those would combine to make 0. So now, look at the relationship between this and this. Okay? X times x gives you the x squared. If you were to FOIL this back together, 5x and negative 5x would cancel to make nothing in the middle. And then 5 times negative 5 makes negative 25. All right? So this really just came from doing the square root of x squared. Okay? It's just taking x squared and splitting it into two equal pieces. And this came from doing the square root of 25. Because these were both perfect squares. Okay, they were both things that I could take square roots of. I could split them into two equal factors. Okay, and then also notice your signs. You've got one positive and one negative. So really, if I gave you something as simple as like x squared minus 36, I want you to be able to look at this and say, oh, well, that's a perfect square because it's something being squared. That's a perfect square because it's 6 squared, right? And so this would be x plus 6, x minus 6. It should be that easy, okay? Now, what I do want to point out is this only works when you've got subtraction in the middle, which is why it's called difference of two squares, okay? Because that negative sign is what allowed us to have a positive 5 and a negative 5. If that was a positive 25 back here, then I would have either needed a plus plus or a minus minus, and neither one of those would have canceled out to make 0 in the middle. So this process only works when you've got perfect squares here and here, and when you've got subtraction in the middle. So you notice these all have subtraction. And I think the reason people have a hard time with this is just they don't recognize the problem for what it is. Okay, so hopefully those perfect square numbers will jump out at you. 9, 25, 81. I hope you see those numbers and think immediately of perfect squares. Okay, so let's try applying this same method to this first example problem. X squared minus 9y squared. I know I'm going to have two sets of parentheses. I know one's going to be a plus and one's going to be a minus. And then it's just a matter of thinking, how would this split and how would this split? Okay, and it should split into like two equal pieces if they're perfect squares. So x squared would become x and x. 9y squared, you can take that in pieces. So the 9 would split into 3 and 3. And the y squared would split into y and y. So you would have x plus 3y, x minus 3y. Okay, for this next one, parentheses, parentheses, 25 x to the fourth y squared. That's a perfect square, right? Because this is a perfect square, this is a perfect square, this is a perfect square. Really, anytime you have even powers, I should mark that down. Even powers are perfect squares. Okay, so this would break into 5x squared y and 5x squared y. And if that was confusing, let that sink in a minute. Multiply it back together in your head. 5 times 5 is 25. X squared and x squared makes x to the fourth, and y make y squared. 1 plus, 1 minus. 289, you might not know that one off the top of your head, but if you needed to in your calculator, you could do square root of 289. It is 17. And then if you took z to the 6th and split it into 2 equal pieces, it would be z to the 3rd and z to the 3rd. Sorry, I kind of crammed that in there. But so it should be 5x squared y plus 17z to the 3rd, and then 5x squared y minus 17z to the 3rd. So the two parentheses should look almost identical when you're done, with the exception of the plus minus. Okay? And that's what allows you to, when you multiply things back together, cancel out that piece that would normally show up in the middle. Okay? All right, this next one's kind of interesting. So if I split 81 into 2 pieces, I start with 9, and then 256. Again, you could take the square root of 256. I get 16, and m to the fourth split would be m squared. And then same thing, 9 minus 16m squared. And then look what I'm left with. Specifically look at this one right here. Okay, do those numbers jump out at you at all? Hopefully. 9 and 16 are both perfect squares again. And m squared is a perfect square as well. So this right here is another difference of 2 squares. This one can be broken down further. Okay, this one right here could become 3 plus 4m and 3 minus 4m. Just like before, these are both perfect squares. I've got subtraction in the middle. Now, this one can't break down any further because it's got a plus in the middle. This method only works with subtraction. Okay, so this parenthesis is going to just stay as is. 9 plus 16m squared. So if I said to factor, you're not all the way factored until you're broken down as far as you can go. So you would want to break it all the way down to that point. Okay, that's really it for factoring difference of 2 squares. I'm going to do a separate video with the next section, which is perfect square trinomials.